Well, hello, my little algebrainiacs. Welcome to the Johnson Kendra Video Hour.
But it's not an hour.
Yes, but ours is to reason why. Why do we know f of x equals y? Okay, let's get to it. All right, inverse functions and relations. This is part two, so it gets a little trickier in part two. These we're going to talk about domain and range, which can vary. You have to be very careful. And we're also going to talk about the inverse, or whether it's a function or not.
Let's talk about this lingo here, or some notation, maybe we should say.
Uh-huh.
So you're going to start seeing this in your instructions in your textbook. So that f to the minus 1 of x, all that really means is to find the inverse.
So it doesn't mean put f on the bottom.
Right.
That's different. This is a notation difference. It's not really mathematical.
So that's just asking for the inverse.
All right.
So don't be freaked out when you see that.
I won't freak if you won't freak.
Okay, so we've got three different examples here, and they're going to hopefully cover the three scenarios I think you're going to come across. So we have, the challenge tends to be the domain and range stuff. So we've got some hints for you. It's a lot of times easier to think about what you cannot have instead of what you can have. So things that cause us problems would be negatives under square roots, because those would produce imaginary numbers, or zeros in denominators. So if you ever have x's in the bottom of a fraction, then we have some restrictions on the domain and the range.
Maybe we could add a third one there and just say square roots are positive.
Oh yeah, that's going to definitely, square roots, should we say produce?
Produce positive results.
Yeah, those are good things to think about. Also, what about even exponents?
Ah, x squared or x fourth, those are going to be positive results too.
Okay. Those are good things to think about.
Okay.
All right, let's start with our first one. Number one, f of x equals the square root of x plus 1. So remember, when you're finding the domain, you're being asked what can x be, and it's much easier to think about what it cannot be. So we have a square root, so that means we've got one of our situations going on here. We are not allowed to have negatives underneath there, and if you think about, the number line, we've got negative numbers over on this end, and then we've got positive numbers over on this end, and then what's right in the middle of those?
0.
So what we want to do is find out when that's going to be 0 underneath the radical. So I'm going to take the item from underneath the radical and think about that, or solve it. You can do this mentally.
Yeah.
Negative 1 is going to be the cutoff point. So that means when you plug in negative 1, we'll get a 0 underneath there. Now, is it legal to have a 0 underneath a radical?
Sure.
But we can't have anything smaller. If you think about plugging in negative 2,
uh-oh,
that would be the square root of negative 1. We're not going to be able to do that. So negative 1 is definitely the cutoff point. We cannot have numbers smaller than it. That means that we can have numbers that are bigger than that.
right. So if you put a 3 in there, you'll get square root of 4, which is a number, which is an answer.
That's great.
So to the right of negative 1.
Okay, now to determine the range, that's asking what kind of y answers we get. Remember, y is the same as f of x. So when I use these numbers, what kind of numbers do I get out? Well, that's referring to another one of these.
Aha.
When I take a square root, I only get positive answers, but we did talk about having a possible 0 underneath there. So for my range, it's going to be y is greater than or equal to 0.
So you'll always get answers that are 0 or higher.
Correct.
Cool.
Okay, next step is to find the inverse equation. Remember, the f of x is just like a y, and we practiced this in the part 1 lesson. To find the equation, all you do is you switch the x and the y. So x equals the square root of y plus 1, and then we're solving for the y value. To undo the radical, I'm going to square both sides.
Oh.
X squared equals y plus 1, and then I would isolate the y by subtracting. So here I'm going to use that fancy notation. That's the same as y equals x squared minus 1.
Nice.
Okay, so that's the second answer. Here was really the first thing we were being asked. The second thing was to find the inverse, and then now actually we're going to find the domain and the range of the inverse. And you're probably thinking, oh, I got to go through and do that all again. But remember when we made those t-charts? we talked about originals and inverses. What's that special relationship there?
You just got to switch them.
Flip them around. So your domain represents x's and your range represents y's. So what I'm going to do is use the y values, the numbers greater than 0. That's now going to be equal in my domain.
But domain is always x.
Correct. I'm going to take the x values from my original, greater than or equal to -1. Those are now going to be my range values, and you always use range for y.
So x and y stay the same. It's just those number values that are going to switch.
Oh, there's a fourth thing. Tell whether the inverse is a function. The only time we're going to have something that is not a function is if there's plus or minus. So this is a function. So item number 4, it is a function.
Don't forget the fun.
That's right.
All right, well, that's kind of a lot to think about.
It is.
I need a lot of practice to get used to that domain and range.
Let's talk about a different scenario here. So we need to, here's our original, 3x squared plus 4. We need to think about restrictions on the domain. So look at your little list. We have no square roots, no fractions, but we do have an x squared. That's actually going to affect the range. So if I think about what I'm allowed to plug in, I can do anything.
Anything's legal. You can square a 0, you can square a negative, you can square a positive. So anything's legal to put in for x.
So how about when I do that, when I plug in, for instance, -1, and I square it, what happens to that thing?
It turns positive.
Always turns to a positive. What if I take a positive number and I plug it in?
It's still positive.
Still positive. How about if I plug a 0 in?
Well, you're going to get 0.
Okay, so that's kind of a unique one. All the other numbers were bigger, bigger, bigger. So what you want to think of when you have something that is x squared, you want to say, okay, the smallest number I'm going to get out of that portion of the equation is a 0.
Uh-huh.
And then I'd have to add 4 to it.
So 0 plus 4. So 4 really is the smallest that our answers are going to be, because that first part is either going to be 0 or bigger.
Because of that exponent.
Aha. You really got to think about these.
It's tricky. And if you're not sure, just do some testing like we were doing there.
Yeah, try a positive, try a negative, and try 0 and see what happens.
Okay, so that's item number 1. Second thing we need to do is find the inverse equation. When we do that, we switch the x and the y, and then we solve for y. So we're going to subtract 4 to start. X minus 4 equals 3y squared. Now, can I square root right away?
Gotta get it alone first. Divide by 3.
I'm pretty sure your book's leaving your fractions like that. Okay, and then the last thing is to get rid of the the exponent by square rooting. Remember, anytime you do that, you need plus or minus on your answer. So my inverse, I'm going to go back to my fancy notation, f to the -1 of x. That makes it so that you don't have to write inverse. You just know that this is the inverse of f of x. Is equal to plus and minus the square root of x minus 4 over 3. And you got to be a stickler here. Notice my root is big enough to cover the top and the bottom of the fraction. If you were to write this, you're wrong.
Yeah, that's not quite right.
So make sure you're careful. So that's item number 2, finding the inverse equation. Item number 3 is finding the domain and range of the original. And luckily, we've done all the hard work for that. So what was the domain in the original? That's the range.
Cool little R there.
Thank you.
Mm-hmm.
Had lots of practice. And then greater than or equal to 4, that was my y values in my original. Therefore, greater than or equal to 4 are going to be my x values in my inverse. Last thing, item number 4 we need to do is say whether or not this thing is a function.
It's got plus or minus.
So it is no fun.
No fun, cushion. All right.
Because of plus or minus. You want to take a stab at it?
Yeah, let me look at this next one.
All right.
All right, this one looks like just a plain old ordinary line. So, domain and range, is there anything I cannot put in there? Can I put a 0?
Yes.
Can I put a negative?
Yes.
Can I put a positive?
Yes, there's no square root, there's no fraction.
So x is all part of the reals. Now, once I put those in, 0, positive, or negative, is there anything that won't be an answer?
Well, I know that on the last one we talked about how that exponent was going to produce, when we squared it, it always turned positive.
Okay, but am I ever going to get a negative out? Let's just try one. If I put a negative or a 4 in here, I'll get 10 minus 12. That's negative 2, so I will get negatives.
Okay, so because there's no exponent of 2.
Right.
There's
It's just
nothing
a
weird
regular
going on.
x. So I think I'm going to have every answer possible too.
And that's always going to be true when you have a line.
Plain old line, you're allowed to put anything in and you'll get anything out because lines go on forever in both directions. Okay, so the next thing we have to do is find the inverse.
So switch the x and the y.
So inverse of our function. All right, here's how we're going to do it. So I'm going to make it y equals 10, oops, well that's just the original, minus 3x. So x equals 10 minus 3y. So I'm going to subtract 10. So I have x minus 10 on the right and negative 3y on the left. Then I'm going to divide by negative 3. So you can leave it x minus 10 over negative 3, or you could put the negative on the top and make it negative x plus 10 over 3. I think we'll accept either one of those answers.
Okay, that's the equation.
So that's our inverse. Now we have to figure out the domain and range of that, but guess what?
They're reals and reals.
Yep, they both switch, so we still have reals and reals. And if I have a line going like that, its inverse is going to look like that. Do they look like functions?
Yeah, they pass the vertical line test.
They do. The only part that might not is if it's a horizontal line, because then the vertical line will not pass the vertical line test.
And I don't think they're going to see any of those.
Okay, just in case. All right, now we come to the really fun stuff, composite functions. So if we go back to number 3, we found the inverse function to be the x minus 10 over negative 3. We did that on the screen before. So what we're going to do right now is we're going to put a 2 in for that function.
Wait, this is like fog and goth.
Right, but now we're having FOF negative 1. So it's the same deal. We just have an inverse instead of a g function. We're going to have an inverse function.
So we still need these two equations.
Right.
Okay.
So usually you're going to have to find the inverse one before you start, but we've already done that, so we're just going to plug in the 2 and see what happens. Okay, so in this one I'm going to put a 2 in right here because it's telling me use that 2. So 2 minus 10 over negative 3, that's negative 8 over negative 3. Cancel out the negatives, I get 8/3.
Positive.
Oops, positive. So if in my input is the x, the domain, I put in a 2 and I got 8/3 to come out. Now what I'm going to do is I'm going to take that 8/3 because the 2 is going into there and then that goes into the f function. I'm going to put the 8/3 right here and see what happens. So 10 minus 3 times 8/3, think of it as 3 over 1. 3's cancel, I get 10 minus 8 equals 2.
Wait a minute. That's what we just started with in the very, very beginning.
So on this side, I put in, oops, I always want to do negative. I put in 8/3 and I got out a 2.
Okay, let's look at this for a second. So this is my f of x equation.
Right.
And this is my f to the minus 1, meaning inverse of f of x.
Right.
And what I know about inverse equations is that their domains and their ranges are flipped around. So you used a 2 as an input, got an output of 8/3. Then you used the 8/3. Well, without doing any math, because they're inverses, we should know that the output is automatically going to be 2.
So can we come up with just a shortcut here so we don't have to go through all this rigmarole?
We sure can.
Woohoo!
I hope that they understand the rigmarole. But this is true of any composite of an original and or an inverse.
Okay.
So it works in either order. We did this where we plugged into the inverse first and then plugged into the original, but it works the other way also. They're always going to undo each other. So whatever your input was, which was the 2 in our example, that's just your answer.
So choose your answer when you have FOF, -1 or -1.
So if we had this,
I'm smart, that's 1,000.
right?
Woohoo! How easy is that? Because the inverse and the regular function undo each other.
Right.
Very cool.
This is some crazy stuff.
It is. All right. Good job, everybody. We'll see you later.